So the real life scenario is on the back. It says the depth of water just offshore is measured over an 18-hour period starting at midnight. The data collected is given in the table below. Use the data to do the following. Okay, so 18-hour period. Obviously, we know there's tides in the ocean, so the water level goes up and down. So that's what this is going to be showing, the water level going up and down. Here we're going to use our GDC a lot, so it's important you know how to do this for sure for the exam. Use the stat function on your GDC to plot the data. Here's the data. Here's midnight, 2 in the morning, 4 in the morning, 6 in the morning, 8, and so on. And here's the depth of water. So first of all, I'm going to use the stat function to enter that data. So let's get your calculator going. Here it is. Press the stat button. We're going to go to 1 to edit our lists. If you have data in your list like I do, you go to the top where it says L1 here. You press clear, enter, enter, it clears it. Now I'm going to go to the top of the other list and clear it as well. Clear, enter. Okay. So in list 1, I'm going to enter my x values. These are going to be my x values. The independent variable is the time. So it's going to be 0, 2, 4, 6, and so on. 0, enter, 2, enter, 4. Okay. Okay, I think I got all the values. Yeah. Okay, now I'm going to go to my other list. Okay. 6.7, 8.3, okay, 6.7, enter, 8.3, enter, 9.1, 8.1, 9.1, 8.1, 6.4, 9.6, 7, 4, 9.2, 8.2, okay. Okay, I entered all my data. I hope that gave you a chance to do yours as well. Now I'm going to go to second stat plot. Make sure my plot is on because I want to see that statistical data. Mine says off. I'm going to go there. I'm going to turn it on. Okay. Now I'm going to do graph. And I see the points. All right. But maybe my window is not correct. Anyway, it graphed the points because I just turned on my stat plot, but my window is probably not good. Let's change the window so it matches our data here. It's going to go from 0 to 18 on X. And maybe, what's the lowest point? 5.6, highest 0.9. So I'll go from 5 to 10. So let's see, window, X values. I'm going to go, let's go -1 just to see behind it one. And then this has to go to, let's say, 20. 1 is fine. Or let's make it 2. 2. Y min, okay. What did I say? 5 and 10. Okay, graph. Alright, those are all my data for the tides. It goes up and down, up and down. Alright, that's good. That's good. Let's see, window, something doesn't look right there. X min, okay, no, it's fine. Okay, so there it is. Now we're going to have to find a cosine function to match that. I plotted the data, so I've done the first step. B, create a cosine model. Okay, so just like we did on the front, we need a cosine model. So let's begin with the amplitude like we did before. Okay, always good to get the amplitude first. And remember the amplitude, we took the, if you look back on the first one again, remember to find the amplitude, we took the high point and the low point, the max and the min, you subtract them, and then you divide by 2 and it gives you the amplitude. So let's try that here. What's the max point? Max point is 9.2. Min point is minimum 5.6, okay? I'm going to subtract those and divide by 2. 9.2 minus 5.6 is 3.6 divided by 2, and that equals 1.8. So the amplitude is going to be 1.8, all right? Let's do the vertical translation next. Let's look at the calculator for a second. So 9.2, 5.6, and the amplitude is 1.8. So there's my 9.2, there's my 5.6, and I subtracted those. 9.2 minus 5.6 was 3.6, and I divided by 2 to figure out the amplitude. So the center line would be somewhere here, and it would be 1.8 up and 1.8 down. So 1.8 up, 1.8 down would get us the amplitude from the center line. So now where's that center line, right? If the amplitude is 1.8, so if I'm looking at this data, this is my top point, and I go down 1.8, I'll get to the center line. If I go to the bottom point and I go up 1.8, I'll get to the same center line. So I'll do that first, the top point minus 1.8 to get to the center. So top point was 9.2 minus my amplitude, 1.8, and that equals, let's see, 8.6, 8.4, and 7.4, right? Alright, 7.4 is my vertical translation, because remember, if that is where the center line is, and originally a cosine graph has a center line at 0, so let's go back to this diagram one more time, right? Original cosine graph has a center line at 0, and now my new one has a center line at, what was it, at 7.4? So my new one's at 7.4, that means this center line must have moved up 7.4. So in our new situation, on here again, the center line must have moved up all the way up to here, which is at 7.4. So that is our vertical translation. Now let's do horizontal translation. And remember, for the vertical, you can confirm, or you could have done it from the bottom point as well. So I could have done the bottom point, which is 5.6, added the amplitude to take me up to the center line, and those two added also gives me 7.4. So 7.4 is where that center line is, all right? It's right in the middle with the amplitude either way. Horizontal translation, this is how it moved from, moved over, right? So let's look at the graph again. Here's the upper point right here. And remember, normal cosine graph, let's go back to the diagram one more time. Normal cosine graph begins here at 1. And now mine, it has the top point. The top point was here at 0 on the x, and now the top point is not at the 0 on the x. Where is that top point? So let's check the data. The data says the top point, which is 9.2, 9.2 occurs, well, it occurs here at 16, and here's 9.1, which is close to 9.2, but anyway, 9.2 is at this value here, 16. So that will tell you maybe the translation is 16. But anyway, I want you to think about this a little bit more here. 9.1 is very close to 9.2, right? This data is not going to be perfect, but if a cosine graph is going to model it, then some of these data points are going to be a little bit off, right? And you can think of the 9.2 as basically being the same as 9.4. So for example, goes here, goes up to 8.3, up to its upper point, down to 8.1, down to 6.4, 5.6. Then it's going up again, 6.7, which matches this one, 8.4, which almost matches that one, 9.2, which pretty much matches this one. So you can kind of see it's following the same path on its upward flow here as here. These ones are both off by 0.1, but that's very close. Real life data is never going to be perfect, but it's going to be close to this model we're going to create. So you could say 16, or you could say that this is your upper point, that this is sort of the same as the 9.2. So that's only 4 away from the axis. All right, so again, the regular cosine was here, and now our upper point is 4 away, so it must be a horizontal translation of 4. Okay. All right, so now we're going to find the period. The period is the distance between the upper points, for example. So here's the upper point, and here's the next upper point. So it goes down and up, and then starts all over again. So what's the distance between those upper points? Well, again, those two upper points are 9.1, 9.2, and we're saying they're kind of like the same. They're a little bit off in terms of the data, but let's both say they're the same upper point. So the distance between those is it goes from 4 on the x all the way to 16. So it's gone actually 12 units over. So the period must be 12 units. All right, the period is 12 units. All right, and then remember, when we have the period, we know period equals 2 pi divided by b. So if we want b, that is 2 pi over the period. So b must be 2 pi divided by the period, which is 12. Right? Really important that you can do that calculation there. So the model in this case, regular model, is cosine x. We've transformed it. We begin with this. We need the a value in front. A value is always our amplitude. In this case, we found the amplitude to be 1.8. 1.8 cosine, and then we're going to put the b value in here, which is 2 pi over 12 x. Now we need the horizontal translation, which is 4 units. Close that off, and now we need the vertical translation, which is 7.4. Sorry, forgot the plus sign, 7.4. Okay, make sure that model makes sense. Think about all the steps. This is kind of the goal for today. This is what you need to know how to do. So there's our model. And now we're going to graph it. So the next step says graph the model to see how well it matches the data. Again, we saw some of the points were a little bit off, you know. So let's see how close it is. So let me go to here. I'm going to enter that model. So 1.8 cosine. I'm going to put a parenthesis. Let's see, 2 pi, 2 second pi divided by 12. Close that parenthesis, and then open a new parenthesis, x minus 4, x minus 4, close it, double close it, add the other translation, vertical, horizontal, sorry, 7, oh no, okay, 7.4, okay, enter. Graph. All right, the moment of truth. How close is our model? Oh, pretty good. Look at that. Yay. Oh, very close, very close. That's excellent. Good news. Our model, our equation, which is the model, very closely matches the real life data of the tides going up and down. Excellent. Great. Tides are an excellent example of something that's called periodic behavior in nature. And anything that's periodic and is a consistent period can be modeled using sine or cosine. So great model. Last step. Use the GDC sine regression. All right, regression, the word regression means to calculate the best fit model for something. You might be familiar with linear regression if you have a bunch of linear data and it's not a perfect line, but you want to find a line of best fit. That's called calculating a linear regression, finding the line that best matches some data. In this case, we're going to find a sine curve that best matches some data. So we've just created the cosine model, but we can use the calculator to find the sine model. So here's how you do it. Go to, let's see, stat, calc, all right, and then all down here you can see linear regression, quadratic regression, cubic. Those are all the regressions your calculator can do for you. So if you ever see data that looks like a parabola kind of, you can run a quadratic regression and your calculator will give you the equation of a parabola that matches the data. All right, so now we're going to look down and you're going to see a sine regression coming up. Logistic sine, there it is, sine regression. So this will, your calculator will make a sine. Now it says iterations, that's how many periods. List, it's going to take the data from list 1 and list 2, that's perfect. The period, what is the period of ours? The period we figured out is, I can't remember now, sorry. The period was 12. Okay, so I'm going to put 12 in here as our period. And store the regression. So once it creates the equation, we want it to store it. We don't want to have to write it down. So I want to store it in one of the y equations. So let's see, you're going to go vars and y vars, y variables, function, number 1. We already have an equation in y1, which is the cosine model we made, so I'm going to put it in y2. There, now it's going to go in y2, and now calculate. It did the regression, it's calculating, it is creating a sine function for me. Come on, calculator, there it goes, it figured it out. So now it should have stored it, because I told it to store it. And there it is, y1 is the cosine model I already entered, that we figured out, and now it entered a sine model for me. And now I'm going to graph it and see how close everything is. So there's my cosine model, the one we already graphed. And in a moment, I'll graph the sine one as well. Okay, so let's see what happens. I haven't tried this yet, so I'm curious. There it is. It's the sine model. Look, it's going almost on top of it. So in other words, the sine model it created is very close match, just as our cosine model was, and they're both very good matches for the data. So anyway, sine and cosine waves are they're the identical shape, right? They just kind of one is moved over compared to the other, basically. But there we have it. Hope that helps with that. If you've watched all that and understand it and think about modeling, you will do very well with the practice assignment in the textbook. This is kind of a key assignment for this unit. It brings a lot of the pieces together, so make sure you understand this and try the assignment. All the best to you. Good luck.